Welcome back. This is Mr. Hassan's Maths channel. I'm now going to answer a question from one of the Solomon collection of Edexcel papers. This is from the Mechanics M1 collection. And this is from Solomon I. And this is question number 9, or question number 7 from Solomon I. And question number 9 from my end of topic worksheet on forces and friction for M1. Now, this question is about a car of mass 1,250 kilograms, which is towing a caravan of mass 850 kilograms up a hill, inclined at an angle of alpha to the horizontal, where the sine of alpha is a quarter, well, not quarter, 1/14. The total resistance to motion experienced by the car is 400 newtons, and by the caravan is 500 newtons. Given that the driving force of the engine is 3 kilonewtons, which is 3,000 newtons in SI units, K stands for 1,000 there, show that the acceleration of the system is 0.3 meters per second squared. Okay, so now, as always with M1 questions, drawing a clear diagram that illustrates the situation is always something that will help. Okay, so I'm going to draw an inclined plane. Let me just change that slightly. An inclined plane, gentle incline. Alpha is, this is angle alpha, and we know that the sine of alpha, as it told us, is 1/14. So you have a caravan and you have a car. Caravan and a car. Okay, and these are going up this inclined plane. All right, so they are going up the inclined plane. The car is pulling the caravan. Now C and C is going to not look very good, so I'll put it as A and B. Let's call the car A and the caravan B. So you've got a cable between them. Okay, it's towing cable, whatever, rope. Okay, so that's the cable between them. This is A and this is B. Let's call this the car. This is the caravan. Okay, so you have here their weight. Let me draw the forces now acting on them. Okay, so you have the weight of the car and the weight of the caravan. You have the resistance to motion of the caravan and the car. You have the driving force pulling the engine of the car, pulling it up, the driving force produced by the engine. We also have, what else do we have here? We have the reaction forces, I guess. I don't think we really need them because they already gave us the resistance to motion, so we don't need to use them for anything. So I'll just write that. I'll label this as RA and RB, which I don't think we'll need to find. This is 3,000 newtons pulling this way. This is the car is 1,250 kilograms. So this is 1,250 G newtons, and this is 850 kilograms. So this is 850 G newtons down. This is a resistance to motion of 400 newtons. And this is the resistance to motion of 500 newtons. Now, each of these has a component. Well, I'll do the components if I need them later. So these are the forces acting on these two caravans, or on this caravan and this car, sorry. All right. So we want to show that the acceleration of the system is 0.3 meters per second squared. Of course, inside the system, you have the tension. You know, this is being pulled up by the car, and the car is kind of being slowed down by pulling the caravan. So the caravan is pulling on the car, and the car is pulling on the caravan, you could say. And those two tensions are equal and opposite. Now, what I'm going to do in order for us to show the acceleration is 0.3 meters per second of the whole system is I'm going to consider this as one particle, which means I can ignore the tensions inside the system. So what I'm going to do is I'm going to consider this as just one particle, which is the car and the caravan together. I'll just consider it as one blob, basically, right? Inclined at an angle of alpha to the horizontal. Okay, So inclined at an angle of alpha, the horizontal. Okay, so this whole thing is 1,250 plus 850. So 1,250 plus 850, I think that's 2,100. Yeah, so that's 2,100 kilograms. So the weight is, of course, 2,100 G newtons, 2,100 G newtons. You have the driving force, which is 3,000 newtons. You have the reaction force, which we don't really have to find. I'll just call this the total reaction force for everything. And you have the resistance of motion in total. Okay, so the resistance of motion, the total resistance in motion is going to be 500 plus 400, that's 900 newtons. That's the total resistance in the motion. Then we also got to consider, now what I'm going to do now is I'm going to resolve the forces parallel to the direction of this motion. Okay, so we know that this thing is moving this way. So I'm going to resolve the forces parallel to the plane. Okay, we also know that sine of alpha is 1 over 14. So if I resolve the forces parallel to the plane, then I have to resolve this force, okay, which is the weight parallel to the plane. Okay, so I have to resolve this force parallel to the plane. Let me draw it like that a bit. I don't really need the perpendicular component, but we know from our work that this is alpha. Okay, and if I want to resolve this force, 2,100 G newtons, parallel to the plane, I've got to go away from alpha, or I can think I have to go in this direction parallel there. So this is going to be like the opposite side. So this is going to be using sine. So 2,100 G times sine alpha newtons. That is this force acting here. So if I consider all the forces acting on this whole system, I have the driving force, which is 3,000, minus the resistance to motion, which is 900 newtons, minus this, which is the result, the component of the weight in the direction parallel to the motion, and that's acting kind of down the plane, 2,100 G times sine alpha, and that is equal to the mass times the acceleration. Okay, and the mass of the whole thing is 2,100 times the acceleration. All right, so we have to find this A. Everything else we know. We know that sine alpha is 1 over 14, G is 9.8. So if I rearrange this equation, I have 3,000 minus 900 minus 2,100 times 9.8 times 1 over 14, all over 2,100, and that's equal to 8. So let's see what happens when we calculate that. We can stick that in the calculator. We have 3,000. Don't make a mistake like that. 3,000 minus 900 minus 2,100 times 9.8 times 1 over 14, which is the sine of alpha, and all of that divided by 2,100. And that gives us 3 over 10. So A is equal to 3 over 10. So therefore we can say the acceleration is equal to 0.3 meters per second squared. So we've shown that the acceleration is 0.3 meters per second squared. That's part A of the question done. And now for part B, it says find the tension in the tow bar linking the car and the caravan. Okay, so this is where we can consider one part of the system. So for example, now if I concentrate on just one part of the system, which for example, I think I'm going to concentrate on the caravan, because the car has 1, 2, 3 forces acting in this direction. This has only 2. So if I consider the caravan, there's only 2 forces acting on it that I have to consider. Okay, so in fact, I can just take a little snapshot of this. Okay, and then I won't have to draw it again. So I'll take a little snapshot of this and put it down there so that I can use that down here. Make it a bit smaller, it's too big. All right, so that diagram's already drawn that we need. So what I need to do here is I need to consider the forces only on the caravan. So I'm considering, okay, the forces acting only on the caravan, only on the caravan, which I've called V there anyway, caravan. Okay, that's the only thing I'm considering. So now what I'm going to do is I have to resolve this force parallel to the plane. Okay, so this force, which is the weight, I'm going to resolve this parallel to the plane. So this is going to be 850 times G times sine alpha. Okay, because we know that this is alpha, we're resolving in that direction. We don't need the reaction force here. So we can say if we resolve the forces parallel to the plane, we know that it's accelerating. The whole system is accelerating at 0.3 meters per second squared, and it's going in that direction. So I'm going to take up the plane as positive. I'll have T, which I have to find, minus 500, which is the resistance to motion, minus 850 times G times sine alpha, which is a component of the weight of the caravan acting down the plane, and that's equal to the mass of the caravan, which is 850, times the acceleration, which is 0.3. That's the resultant force is mass times acceleration. That's the resultant force, that's the mass times acceleration. The only thing we don't know is T. So T is equal to 850 times 0.3 plus 500 plus 850 times 9.8 times 1 over 14. And that should give me the tension in the tow bar. Okay, it's a tow bar that's linking them. Let's hold us that now. So what I'm going to do now is I'm going to just put this in my calculator, 850 times 0.3. Okay, and I've got to add to that 500. I've got to add to that 850 times 9.8 times 1 over 14. Okay, and that should give me my answer, which is 1,000. So that's 1,350 newtons. That is the tension in the tow bar. Okay, so there's the answer to that part of the question there, which is question part B. And then part C, it says starting from rest, the car accelerates uniformly for 540 meters until it reaches a speed of V meters per second at the top of the hill. Find V. So let's have a look. We have Suvat. So we know it's traveled for 540 meters. Starting from rest, so it starts at 0 meters per second. V, that's what we have to find. The acceleration we know is 0.3 meters per second squared. And the time, I don't think we need to use that here. So we have to do with S and U and V and A. So that's V squared equals U squared plus 2AS. And we want to find what V is. So V is going to be the square root of, you have U is 0, so it's 0 squared plus 2 times 0.3 times 540. Okay, so that will give us what V is. So that gives us, let's have a look, the square root of, we just have to do 2 times 0.3 times 540. It gives us 18. So we know that V is equal to 18. There's the answer for V. Simple as that. And then for part D, okay, in part D, it says at the top of the hill, the road becomes level and the driver maintains the speed at which the car and the caravan reach the top of the hill. So that means he maintained that speed of 18 meters per second once they got to the top of the hill. So now he's at the top of the hill, so it's all level now. Okay, assuming that the resistance to motion on each part of the system is unchanged, find the percentage reduction in the driving force of the engine required to achieve this. So now the driver wants to maintain the same speed that he got to the top of the hill with. So of course, now he wants to go at a constant speed. So he's got a driving force which is going to be different from before, because before he was pulling the thing up and it was accelerating from rest. Now the resistance to motion are both the same. The resistance to motion are both, that was it, 900? Yep, 900. 500 plus 400. So I'm going to again take this as one whole particle, because I don't need to worry about anything else here. That's resistance to motion. There's no inclined plane anymore. We know the total mass is 2,100 kilograms. And we want to find the driving force. Now what it is we want to find the new driving force. Okay, the new driving force. The old driving force was 3,000 newtons. The new driving force is what is required for this to keep a constant speed, so the acceleration has to be 0. Okay, it's going to go at a constant speed of 18. Okay, that means the acceleration is equal to 0. So F equals ma is equal to 0. So we can say d minus 900 is equal to mass times acceleration, which is 0. Okay, so we can say the driving force has to be 900 newtons. So this is the new driving force. So they want the percentage reduction in the driving force. So percentage reduction, okay, the percentage change or you know, the decrease is the difference. So it's 900 minus 3000 divided by the original. Well, the original was 3000. Okay, so you end up with, that's going to be minus 2100 over 3000. Okay, so we'll just put that 900. So we have 900 minus 3000 divided by the original force, which was 3000. And that gives us minus 7 over 10. So it's minus 0.7. So therefore, we can say the percentage reduction we actually want as a percentage. So let's just do that straight away. Multiplied by 100%. Okay, so that's going to give us minus 7 over 10%, which is minus 70%. Okay, minus 7 over 10 times 100, sorry, times 100%, which is minus 70%. Therefore, the percentage reduction, we write it as is 70%, because reduction means, you know, we call this percentage change. Okay, reduction means going down, so we don't have to put minus. The percentage reduction is 70%. Okay, so the percentage change is minus 70%. That means the percentage reduction is 70%. So he has to use 70% less driving force in order for them to maintain that speed of 18 meters per second once they have reached the top of the hill. So that's the answer to part D, and that concludes this question, which is, I think that's the whole question. Yep, that's the whole question. That concludes this question from this Solomon I paper and from this end of topic worksheet number 5. Other questions from Solomon I M1 collection, if I answer them, will be in the playlist that should appear in this region over here. Other questions from this worksheet of forces and friction from my M1 worksheets from Edexcel can be found in the playlist over here. Other questions which deal with this topic of forces and friction, inclined planes, and all these kind of things, you can find in the playlist over here. And you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.